Hello everyone. So today we'll see the project convolution neural network based Unet model. Using this Unet model, we are going to do lung image segmentation. Okay. So here we are using the Unet. Unet is nothing but one of the convolution neural network only. This is specially designed for biomedical image segmentation. Okay. So there is a encoder and decoder in this unit. So here this is the complete architecture. Here this complete process is encoder. So from here decoder process will happen. Okay. So here we have to give input as a color image as well as mask image. Mask image it's look like black and white or any multicolor image. Segmented one, that is a ground truth image. So based on this, we are going to train the model. Whenever you give this type of color image, I need to get as a masked image, like segmented image. So like this, the architecture, unit architecture is designed. Okay. So now, especially we are going to do in this project for lung, we are going to segment. Here, input image, there's a mask is generated using our Unet model. Okay. So here I'm going to show the data set first. So we have a huge data set, but for the training, I'm using only 10 images of color image. There's the corresponding mask. So validation, simple 3 images I'm using. We can add a number of images. So test images. So here I'm going to open the Python. Python IDE. So I'm using 3.7 Python version. Here, suppose I'm going to do the training process. So this is the training process. So data set training, validation. I'm going to load in this using train generator. Unit model I'm going to upload. Here I'm going to train it, displaying the training and the validation, accuracy and loss. Here, single image I'm going to test it. I'm going to get the precision, recall, F1 score, and accuracy, all the things. Here there is a sub functions are there. Data means data, we are going to load it. So these are all functions for data generator. So it will be load the images. There is a model function. So this is a unit complete encoding and decoding procedure, complete model. So now I'm going to run and show you. Here just I'm giving steps per epoch. I'm giving just one. Number of epoch, I'll give 10. So if you want to train in day, you have to give minimum 100. Number of epoch, 1 or 2 you can give. Or however, more images if you load, more accuracy you'll get it. More epoch if you give, more accuracy you'll get it. So now, for time being, I'm giving 1 steps per epoch and number of epochs will be 10. I'm going to run this. So this process will take some time. So total found 10 images for one class, another 10 images for another class, which means mask and original image. So number of epoch, 1 of 10. Here you can see that initial accuracy will be 48%. and the initial loss will be 0.77%, you can see. So then every epoch, the loss will be reduced and accuracy will be improved. So you can see second epoch, 54% loss, accuracy is increased. So keep on every epoch, the accuracy will be increased, the loss will be reduced. So every epoch, I'm going to save that model, Unet model dot HDF file format. So once it's completed, the model will be saved in the same folder. So here, this one I have trained already for 100 epoch. So this is for now, it is saving it. So this is used for the testing later. You can do this Unet model, any of the medical CT scan, X-ray scan, ultrasound, any of the images segmentation process. So now it will be a 10th epoch. So once 10 epoch is done, automatically the graph will be generated. Loss graph and accuracy graph. So it's generated here. So this is the accuracy graph. So initially the blue color will be training data. So we have split the data set into 70-30. 70% of images will be training, 30% of images will be testing. So initially this is accuracy. So every epoch increased, let's keep on, it will be increased. If you give 100, the curve will be like this. So this is a validation accuracy. Accuracy versus number of epochs. So same like that, model loss. So model loss will be, it should be reduced. It started some 77%. So again, it is increased again. It's going down. If we give more epoch, so you can see the curve. This is loss versus epoch. So here, one image I have tested for the precision recall score, F1 score, Unet model accuracy average, it is 77. If you increase number of epoch, these values will be changed. So the model will be automatically, it will be saved. So the both the model I will show you. So now I'll open the testing code. So here, Unet model 1. So this is actually trained before. So now once you run this, automatically it will ask the images. So now validation images, I'm going to load it. Sorry. First we need to load the code. Okay, loaded, sorry. Run the code. So it will take some time for loading the model. So now we can select the images from the validation, original image, any of the images I can select. Now for verification, okay. So this is a original image, input image which is given. So this is ground truth image. This is 256 cross 256. This is actually output we are getting 512 cross 512. So while calculation, we are doing it for 512 cross 512. Sorry, 256 cross 256 only. We are resizing this. So original image, ground truth image, Sorry, this is ground truth image. This is a segmented image. So here these are all calculation we are doing it for ground truth and segmented image. MSC, RMSC, PSNR, SSIM, UQI, SCC. So these are calculation we are doing it for the testing. I'll do it for another image. This is a segmented image. This is a original ground truth image. For that, the results. So now I'll do it for whatever we trained now. So we have trained only 10 epoch. So for that, what is the result we are getting? We see. So this is a segmented output. Actually, it's not properly trained. Thank you for watching.